Now, Chapter 10 is going to be on exponential functions. Before we get into exponential functions, though, you have to understand what it means to have something raised to a fractional power, like a rational number, like right here, b raised to the p over q. That just says some number raised to a fraction is equal to, you take the numerator of the fraction, okay, and that is what you're going to raise the b to, but the q on the bottom, the denominator, is going to be your root. So if it's the square b, if you wanted to write the square root of b, you would write b to the 1/2. That would be the square root of b. If you wanted to write the third root, the cube root of b to the 5th, you would write b to the 5 over 3, and your cubed root would go here, your b inside, and the whole entire thing would be raised to the 5th. Okay, so as you can see, this is how it goes. Out here is the q goes outside and the p goes on the inside. They basically mean the same thing, so a lot of times I jump right from this one right here, I forego the parentheses, and I go right onto this form right here. As you'll see down here in problem 1 on page 458, here's some that they would like you to simplify. If you take 81 to the 1/2, this means 81 raised to the first power and then take the square root of it. And that's what this rational exponent means. So inside it would be like this. As you see, I went right from the first step right to the second over here, or the third. And so the square root of 81 to the first, or 81, is 9. Pretty straightforward. Now, problem 6, they have 27 to the 2/3. So 27 will be squared, and then we will take the cubed root of it. So if you think about it that way, the numerator raises the number to the power, and the denominator takes that root of it. And so as you can see here, 27 squared is really 3 to the 6th, because 27 to the first is 3 cubed. So 3 cubed times 3 cubed is 3 to the 6th, which means basically, when you think about this, as I've told you before, when you have something in here, all you really have to do is take the root and divide this power, the exponent in here, by the root, and you'll get 3 squared, right? And 3 squared is 9. Now, problem number 11, they give you one to a fractional exponent, which I just translated into a fraction, or a decimal into a fraction, I mean. And so now this one's negative, but that just says take the reciprocal. Take 4 to the -1, which you know is 1/4. It's the reciprocal of the 4. So then take the square root of it. So that becomes the square root of 1/4, which is 1/2. And down here, 27 raised to the 4th, all raised to the -1/12. Says take 27 to the 4th, this whole thing in parentheses, and raise it to the -1 power, which means put it on the denominator, and then take the 12th root of it. Now, if you think about this, you can use your same laws that you've all learned about exponents, and when they're right next to the parenthesis, you just multiply them. So this could be the same thing as 27 to the -4 over 12, which is why I did it this way, because it just looks easier that way. Because now 27 is raised to the -4, which means it's going to be 1 over 27 to the 4th, and then you're going to take the 12th root of it. But if you look at this fraction, you can also reduce these powers. So this power becomes -1/3, which makes this a lot simpler, because 27 to the -1/3 says just put 27 on the denominator to the first power, which is what the -1 exponent does, and then take the cubed root of it. So the cubed root of 1 over 27 then is equal to the cubed root of 1 over 3 cubed, because 27 is 3 cubed, and I have 3 factors of 3, and I have index of 3, so I bring the 3 out, and remember, it comes out in the denominator here because it is on the denominator. And that's how you do this problem.